Hello, this PowerPoint is about poor air quality in the work atmosphere. The chemical of my choice is carbon monoxide, which impacts the body when inhaled. This chemical is very poisonous, and once inhaled into the body, it displaces O2 in the blood, which causes short breath and hence resulting to death. With much exposed to carbon monoxide, one can prolong brain damages and eventually result to death. CO2 is a chemical affixant. It displays O2 in the blood, thereby suffocating the person exposed. Small dust particles may remain airborne for long periods, while large particles settle more quickly. However, particles that have settled may be easily resuspended in the ambient air by currents of air or other disturbance. Drapery, carpet, and other places where dust collects can harbor these contaminants. Dirty cooling coils, humidifiers, condensed drains, and ductwork can incubate bacteria and molds. Areas with high humidity can accelerate the growth. The most common sources of biological air contaminants are moisture-laden areas that support the growth of mold and bacteria present in the air. The OSHA permissible exposure limit for CO is 50 part per million as an 8-hour time weight average. The National Institute for Occupational Safety and Health has a recommended exposure limit of 35 ppm as a 10-hour TWA. According to the American Conference of Governmental Industrial Hygienists, the threshold limit values for CO is 25 ppm as an 8-hour TWA. Carbon monoxide detectors, in addition to having a professional inspect appliances and furnaces, commercially available carbon monoxide detectors can be used to monitor the levels of carbon monoxide in buildings throughout the year. The manufacturer's instructions on placement and maintenance should be followed. Common indoor air contaminants. The purpose of this section to provide additional information about several common indoor air contaminants. Carbon monoxide is a colorless, odorless gas produced by the incomplete burning of materials containing carbon. CO poisoning can cause brain damage and death. Common sources of carbon monoxide are leaking vented combustion appliances, automobiles exhaust, and parking garages. When not properly ventilated, CO can build up. Employees exposure to low levels of CO may feel sick with headache and nausea, and will feel better once exposed to fresh air outside. However, their symptoms will reoccur shortly after returning to their workplace if CO is not eliminated. Carbon monoxide poisoning symptoms due to low levels of CO can be confused with influenza symptoms, food poisoning, or other illnesses, and can be long-term health risks if left unattended. Some of these symptoms of low-level poisoning are shortness of breath, mild nausea, and mild headaches. Exposure to high levels of CO can lead to brain damage and even death. Adequate ventilation is important for control measures. The OSHA exposure limit for CO is 50 parts per million as an 8-hour time weight. The National of Occupational Safety and Health has recommended exposure limit of 35 ppm as a 10-hour. According to the American Hygienist, the threshold limit value for CO is 25 ppm at an 8-hour TWA. Carbon monoxide, in addition to having a professional inspect appliances and furnaces in buildings throughout the year. The manufacturing structure on placement and maintenance should be followed. Is a chemical asphyte is displaced on O2 in the blood, thereby suffocating the person exposed. Small dust particles may remain airborne for long periods, while large particles settle and move quickly. However, particles that settle may be easily suspended in the ambient air by currents of air or other disturbances. Drapery, carpet, and other places where dust collects can harbor these contaminants. Dirty cooling coils, humidifiers, condensed drains, and ductwork can incubate bacteria and mold. Areas where high humidity can accelerate the growth. Violet organic compounds, VOCs, refer to organic chemical compounds that have significant vapor pressures and that can adversely affect the environment and human health. VOCs are emitted as vapors from certain solids or liquids and include a variety of chemicals, such of which may have short and long-term adverse health effects. Concentrations of many VOCs are consistently higher in indoors, up to 10 times higher than outdoors. VOCs are emitted by a wide area of products numbering in thousands. Examples include plants, paint strippers, cleaning supplies, pesticides, building materials, office equipment, copies and printers, correction fluids, and carbonless copy paper. A graphic material including glue and adhesives, permanent markers, and photogenic solution. More commonly known VOCs include benzene, formaldehyde, and methylene chloride, triglyceride, and tetraethylamine. Exposure to VOCs can result in both acute and chronic health effects, depending on many factors such as the level of exposure and the length of exposure. A few VOCs, such as benzene, have been directly linked to cancer in humans and other suspects of causing cancer. People today spend most of their time at home or in offices. Long-term exposures to VOCs in the indoor environment can contribute to IAQ-related problems. In offices, VOCs results from new furnishings, wall coverings, and office equipment such as photo machines, which can off-gas VOCs in the air. Good ventilation and air conditioning systems are essential to reduce VOCs emission in the indoor environment. Steps to reduce exposure. Use products according to manufacturer's direction. Make sure that plenty of fresh air is provided when using these products. Discard used containers safely. Buy quantities that can be used in short periods of time. Well-designed, constructed, and maintained buildings envelopes are critical to the prevention and control of excess moisture and microbial growth by avoiding thermal bridges and preventing intrusion by liquid or vapor phase water. Management of moisture requires proper control of temperatures and ventilation to avoid high humidity, condensation on surfaces, and excess moisture in materials. Ventilation should be distributed effectively in spaces and stagnant air zones should be avoided. Thank you.